Hi, year 11s. Today we're going to look at 6.3 populations and samples. To start with, let's understand the concepts between populations and samples. Here, I've got an example. A year 11 student who are taller than 1.6 meters in high school. We want to know the proportion of year 11 students who are taller than 1.6 centimeters, 1.6 meters, sorry, 1.6 meters. Yeah, what we do is, I can draw an oval which represent the population, which means I'm gonna have a bunch of dots in here, and every single dot means the height of a student. Okay, so I'm gonna have, let's say we have 200 students, 200 year 11 students. So that's a fairly big school, 200 year 11 students. So I'm gonna have 200 dots, but I'm not gonna draw all of the dots. You know, there are gonna be 200 dots. So 200 individual heights. Okay, this is called a population. So that's all the heights you have in this data pool, Okay, but you are interested in the proportion who are taller than 1.6 meters. A more efficient way of doing this, instead of asking everyone the height, because some student might not be willing to tell you, and it might be hard to collect data in time. So what we could do is we randomly choose some students from this data pool. Okay, some year 11 students. Let's see, we have chosen one, and I picked 3 students. So these are the 3 students I picked. Maybe that's too small. So let me have a bit more. Okay, another 2 students. So I picked these 5 students. Okay, 5 students. I look at these 5 data, and then I figure out the proportion of the students who are taller than 1.6 meters. So let's say one is 162, one is 160. I'm talking about centimeters. 162 centimeters, 170 centimeters. Okay, and 156, 158, and 162. So I just made out these numbers. All right, and from those ones we can see the proportion for this sample. This is called a sample. Okay, that's a sample we picked. The proportion for the sample, p hat. This is read as p hat. If you're talking about sample proportion, this is p hat. And that's just equals to the number of students who are taller than 1.6 meters. So 3 students out of the 5 students we've chosen. Okay, so the proportion would be 3/5. All right, this number, it's very unlikely to be the same proportion, exactly the same proportion as your population proportion. Okay, understand the difference. So this is a sample proportion. Sample proportion. And we're using the sample proportion to estimate, we're just using this more efficient way to estimate your population proportion. Your population proportion. Okay, so we say, given this sample 3/5, we are estimating. So we claim the proportion of the school, the year 11 students. There are 3/5 of the year 11 students at the school who are taller than 1.6 meters. That's what we are trying to do. Okay, we're using the sample to estimate the proportion of this population. All right, and as you know, these are the 5 people I've picked. What about I picked another 5 people? So like here and here, 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 here. Okay, I take it out. I've taken it out. All right, I'm gonna have 5 different data. This is gonna give me a different proportion. Let's say this has given me, let's say 2/5. All right, you can see this proportion is changing from what what the data you have picked. Okay, so in reality, this p hat is a random variable, and in probability in probability and the statistics, we use the capital T. So that's an uppercase capital T, P, I mean, uppercase capital P to represent this random variable. So that's a random variable because it's changing as your sample changes. Okay. All right. By understanding this knowledge, let's have a look at work example 6. A scientist wishes to study pollution in a river. He takes a sample of 42 fish to see what proportion have mercury poisoning and finds that 12 are poisoned. What proportion of fish have mercury poisoning? Okay, so we're using the sample to, estimate the pollution in a river. Okay, it's very unlikely to have the exactly same proportion, but it's a very good estimate. Okay, it's a very good and close estimate. So your p hat, the proportion, is going to be 12 poisoned, so 12/42 fishes, 42 fish, 42 fish, and it's simplified, divide by 6, 2/7. All right, so we can say approximately. So therefore, approximately 2/7 of the fish were poisoned. Okay, so that's application of sample proportion. All right, here's another one. Toss 2 dice 80 times, record the total sum of each outcome, and we find the sample proportion of the number of times the total is a prime number. All right, so this 80 times, as I mentioned last lesson, in your exam, in your year 12 exam, you're not going to test it on generating data. So in this section, this one, the textbook is kind of assuming you to generate a group of data. But for me, I think we just use the data they have generated. So like here, that's a set of data that the textbook has generated for us. So 80 times. And in this table, we can see the prime number have been colored orange. All right. So the p hat is just the number of orange numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, let me double check if I counted right or wrong. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So 31 number out of 60 number, or prime number, okay? 80, sorry. We've toasted 80 times. So 31 out of 80 would be prime. So that's your proportion. A very good estimate of your population proportion. Okay. All right. Next section is sample means. So very similar to what we've done before. You have your data pool. So that's your population. Okay, population. All right. The only difference between this one and the previous one is when you have picked your sample. Okay, let's pick not four people. Let's say these are still the height of year 11 students, and you're gonna have 4 numbers: 161, 162. I'm just making this up. 158, 172. Okay, and your sample mean in statistics, it means average. All right, so the average of these 4 students would be the sum of the numbers divided by the number of students. So X bar, we use X bar to mean sample mean. So X bar, actually this is X bar equals to 161 plus 162 plus 158, 58 plus 172 over 4. Okay, so at this number, it's gonna be the sample mean for this group. And as very similar to the previous one, if you pick another 4, might come from here. And this is gonna give you a different, let's say this is X1, X2. This is gonna give you a different X sample mean. And this one, the sample mean is also a random variable. So we use the capital letter X to represent it. Okay, let's have a look at the application of sample mean. How fast can an average under 16 boy run 100 meters? A quick internet search. So that's the data they have found. So 30 numbers here. Okay, recorded from 2 different athletics calibers. Okay, 2 different athletics calibers. Find the sample mean corrected 2 decimal places. So that's the sample we found. So the sample mean X bar is, we use this sigma, a Greek letter sigma, means the sum of all the numbers. Okay, the sum of your X over N. So we're gonna add all these 30 numbers together. So 11.48 plus ... all the way to 11.02 divided by 30. I'm just copying the answer from the textbooks. So you're gonna have 12.02 seconds. Yeah, 12.02 seconds. So and then we're gonna make a conclusion. Yeah, I'm gonna take a screenshot from the textbook. So B, the conclusion you can make here, the results have been published and therefore from various carnivals. Okay, most under 16 boys do not have the opportunity to compete at these carnivals. Therefore, the sample does not reflect the general population. So this is not a good sample. So when you're taking the sample, it might be good, might be bad. This is not a good one. Because generally, students who are, participating in carnivals are, are good at running. But if you're investigating the average under 16 boy, you're gonna have a range of different kinds of boys. Okay, under 16 boys. All right. So that's my demonstration for this section, and just letting you know, question 3 and 4. Question 3 and 4. All right, from your exercise. So let me show you. Question 3 and 4 from your exercise. You are generating 80. So toss 2 dice 80 times. So you and here toss a die and a coin 50 times. You're generating some data. So I'm happy for you to skip those questions because you never get this kind of question in your test. So I'm happy for you to skip. But if you want to do it, we can have a chat. And also, you can look at your solutions data generated to attempt the question. Okay. All right. Thank you for listening.